So I'm really excited, again, to introduce our next speaker, Sam Guckenheimer. He is working on Visual Studio Team Server and TFS. It's like a DevOps. SaaS.
One engineering
advocate.
System for Microsoft.
One engineering system for Microsoft. And this talk is about moving a very, very large engineering organization to the cloud. And so hearing about the scale and the kind of learning around that. So I'm very excited for Sam. So, okay.
Thank you, Courtney.
Thanks.
Thanks for having me, Courtney. I do everything Courtney says, by the way. I recommend that to you. So thank you for having me at Nike. It was great. Walked through the campus this morning. I love the, the signs focusing on kids' health. I was very depressed to see the 5 years lower life expectancy, but if I try to tell my kids that, it won't work very well. So as Courtney said, I'll tell you a tiny bit more about me. I am at Microsoft, which I think you've heard of, working on things you may not have heard of. So they are a DevOps SaaS called Visual Studio Team Services on the outside. Inside Microsoft, it's the basis of the one engineering system. And it has an on-prem server sibling called Team Foundation Server. We do the SaaS and the server off of one code base. This is going to, OK, so you can ignore the books. Don't read them. They're out of date. The one thing to take away from this slide is that URL at the bottom, aka.ms/DevOps. That's the site I curate that talks about the practices we have and how we work. And you'll see many layers deeper discussion than I will be able to do here in an hour or less. So by all means, oh, don't open that right now. By all means, do take advantage of that. Now, what I'm going to do is spend just a couple minutes on slides, and I'll start with our org chart. I don't know if you all remember our org chart from 2011. This kind of went viral. I refer to those as the days of pistols and silos. We had a policy that started, I don't know when, long before I was at Microsoft. Each division does its own thing, and they have their own engineering system. And the theory behind that was they can do what's right for them and supposedly be more effective and what have you. And that might have been true 25 years ago. The consequence of doing that over a couple decades was that we created a culture where no reuse would go unpunished, where no one could move around from team to team, where, as they told me when I started, literally in my first week, take no dependencies. And effectively everything that I would call a cultural anti-pattern. Fortunately, we got a new CEO. And our senior leadership team said, wait a minute, this ain't working. We need to have a world-class engineering system, best in class, makes our engineers as productive as possible. And what we develop for them, first party, is what we will deliver to customers. It took us a couple years to get up to about 75,000 users. The curve's gotten really boring since then. It was about a year ago. We added maybe 5,000 since. We're pretty much at saturation. So we've stopped counting adoption. We are focusing on satisfaction. Net Promoter Score. And the number one metric is engineering satisfaction. So imagine a place where, as an engineer, all of the source code is available to anyone. So it's now, that's now true by default, where you can contribute improvements to anyone else's source, where company IP is built up of reusable components, where anyone can reuse anything, where you're rewarded for creating better stuff, where you're rewarded for contributing to open source. Even before Monday, we were the top contributing company to open source projects on GitHub. And I'm sure you heard the news. Courtney wanted to say I was here because I was in charge of GitHub. No, don't spread rumors, please. It's maybe 6 months away before that closes, but we're all looking forward to it. Okay, Jason talked a lot about the culture of DevOps. I'm not going to spend a lot of time on that. This will be pretty complimentary. But I want to drill into another definition, not what is DevOps, but what is done. Our definition of done is that code is delivered with tests and telemetry, and that is deployed worldwide, and the telemetry is collecting enough data to substantiate or diminish the hypothesis that led to the changes. Okay. So that's what we think DevOps means in practice, a real DevOps definition of done. So I'm not going to spend more time right now on slides. What I'd rather do is show you a day in the life, or in a few minutes in the life of a change. I am going to flip to my browser, to Chrome. I'll make this a little bit bigger at first so we can read it. Sorry about the small size. And let's start with what a feature crew, that is what we call a squad, sees and how they work. And this is not demo data. This is live. I'm connected to production, so I'm never quite sure what I'm going to see, what I'm going to show you, but we'll see. Okay, so it's sprint 136. Our sprints are 3 weeks long. We work literally around the world. Crews here on the East Coast in Raleigh, and India and Hyderabad, some in Europe. Every crew has their dashboard. They can make it look the way they want. This is one of those crews. The crew happens to be called WIT. WIT is work item tracking. Some of the members are more creative than others in their avatars. I think you'd do a better job than we do here at doing good avatars. We're kind of boring. What are they watching? They're watching, so here, active bugs. There's 17 active bugs on a crew of 13. 13 means an engineering lead, a product owner, and 11 other engineers. We don't distinguish in the career ladder what kind of engineer they are. If that number went up to 48, they would stop all new work and pay down their bugs before they could go forward. As it is, they're pretty well functioning, so they're doing about 1 active bug per person at a time. I can see here there are no P0s. There's, looks like 1 P1 at the moment. They're tracking customer support incidents. It looks like there are 2 that are in the hands of the feature crew. There are a bunch where They're not closed, but they're waiting for confirmation back from customers. There's a work assigned to me. Now, I'm not on that crew, but they have this widget, and because I'm logged in, the system says, hey, you've got these items to do. They're bugs that need to be triaged. There are pull requests waiting for review. I get to see the cumulative flow of work that's been done over the last 6 sprints here. So green is in production, and the blues are work in process. That's a pretty good state. And I get to look at cycle time of work down here, and velocity. And this little widget is tracking what's happening to pull requests across the whole product. Now, I'll come back to that in a minute. The team's probably spending most of, is more likely to start directly on its Kanban board in the morning. Now, let me take a moment on, everyone here does Kanban? I don't need to explain. Do I need to explain Kanban? Anyone? No. OK, great. So their board for this crew is organized in these swim lanes. So these lower ones are planned work. The top one here, I don't know if you can read that, is labeled DRI. DRI is our term for on-call. It's designated responsible individual. And as an engineer, you expect to do like a week a quarter on DRI. And when you're DRI, the expectation is that if there's a live site incident, you are on the bridge with access to the code within 5 minutes during working hours. If it's the middle of the night, outside of working hours, the expectation is within 15 minutes you're on the bridge with access to the code. And if it is outside of working hours and you're paged, the voice that wakes you up is Satya's. It's recorded, but it's the CEO's. So we take that pretty seriously. So this swim lane is effectively reactive work based on what you saw coming in. And the others are planned work. Now, you'll also see up here we should not have more than 12 items active, 1 per engineer. There's a little warning you're at 15, so be careful. And things go from active to peer review to bug bash, let's try it out, to ready to deploy. So as an engineer on this crew, if I wanted to work on this story, I would click on it and create a new topic branch in Git underneath. And that topic branch will live as long as I'm working on that story. And when I close the story, the branch is squash merged and vanishes. So we keep a nice, lean code tree, none of this fluffiness that you used to have. And I would, I can name the branch what I want. I'm not going to create it because this is production and people get kind of pissed off at me when I start screwing things up. But you can see this is, you pick up the idea, you say, I'm going to work on it, and you got your Git branch. Now, I would work on that for however long, an hour, a few hours. At least once a day, I would submit a pull request. And that's what's going on down here. Let's take a look at pull requests. So actually, let me go back one first and then take you to this. So this is an overview of current pull requests. You'll see 10 of them right here in progress. That is, our runner will take every pull request individually so that if it's failing, it uniquely fails that pull request, and the submitter is immediately notified. We fail right now about 1 in 4, sometimes 1 in 5 pull requests. Okay, that's what this 74 point something % means. Okay, now I'm going to show you 2 pictures of these. So if I look at this in terms of what that build process just told me, that says, okay, that one that completed 2 minutes ago. It ran 79,000 tests. They ran in 25 minutes. Now, all of those tests need to pass. So one of the principles we have with regard to making DevOps work is getting a clear quality signal. Green needs to mean green, red means red. So if one of those fails, the pull request is rejected. That's one of those 25% that were being rejected. I can go look at the user story that this is associated with, or go to the change sets here. If I want to go through the pull request details, I can, on many you'll see a long comment history, what have you, and the file changes. You'll see that there are other things that are happening after that build we just looked at. So that is not going to move forward until there's a review approval. All pull requests require the build you saw with however many tests, 70-some thousand. Require a security test. They require a couple pre-production tests. And they require a review approval, which could be done here by someone who's on the right list for that code area. And until those policies are satisfied, that code does not get merged to master. As soon as all those policies are satisfied, it's automatically merged to master. So if I go back here and let me get to dashboard, or let me just open a dashboard. So you've got this volume of pull requests. As you saw, there are 10 running right now. There are probably about 700 a day. And a bunch of them are failing. 1 in 4, what have you. The benefit of that fail rate is that when we look not at pull requests, but at continuous integration, you'll see the last 20 are green. Indeed, let me jump into that. And if I look at the comparable history of the CI builds, you'll see, well, we've failed recently in the last 24 hours. We've failed maybe 1 in 50. Okay, so we're going from 1 in 4 to 1 in 50, which is 12x improvement. Usually this is over 99%. So usually it's even more dramatic. And you'll see there are also several CI builds in progress in parallel. Now, when the CI build passes, that triggers a bunch of pre-production tests. So the tests we saw earlier were unit tests. That is, they run against the binary. They run against binary and immediate dependencies like storage and SQL and so forth. The pre-production tests that run after continuous integration are now running at a higher level in the architecture. They're running against REST APIs. They're using test data like fake IDs and so forth. And there are roughly another 10,000 of these. They're broken into these suites that you see in different rows so that they can run in parallel. And each build up here gets the tests run. And to give you an idea, let me show you what a failure looks like. So you can see this one ran 1,000, somewhat over 1,000 tests. Looks like there were a few failures. We'll show you what those failures look like. So it failed in 2 environments. If I look at the tests in particular, I will see 16 offending tests that failed, okay, and if I click into the test, each test returns corresponding error, corresponding stack trace, corresponding server logs, if appropriate, and for it I can see the history. So by returning this data, and this is the same data you'd get from production, we're effectively doing observability, which Jason talked about. So as a development engineer, I do not have access to production. In fact, no one has access to production unless it's on a time-limited token, which is audited with approval. But we believe that telemetry needs to deliver from production enough data for me to troubleshoot any live site incident as it happens. And in fact, for that, and we do the same telemetry in pre-production in test that you would have in production. So we're exercising the observability of the SaaS as well as the running features and so forth pre-deployment. Okay. Now, and I'll say one other thing about the telemetry. So we're using a service you've probably not heard of. It's public as Azure Log Analytics. We call it Kusto internally. We're consuming about 5 or 6 petabytes a day of data on that across Azure services. So this is very high volume ingestion, and we have very fast querying in a couple seconds or a few milliseconds. Now, these particular builds are obviously not going forward into production because there are a few tests failing. It needs to be pure green, somewhat rare state, and they've been taken out of rotation while someone is investigating them, which is what this means over here. And of course, we track when they last failed. This failed roughly, looks like roughly an hour ago. But you can get a feeling for the rate of builds. We're into 97 builds so far today, CI builds that are being tested. All right. Now, when all of those run green, all of the pre-production tests run green, they are ready for deployment. Let me show you what deployment looks like. So we are, again, we're running a SaaS. We have this, I think now, live in 15 data centers around the world. we have, in this, let me explain this view. This is, every row is an instance of a deployment. You can see this one was started 2 hours ago, a couple 8 hours ago, several yesterday, and so forth. You can see in which data centers, or more specifically Azure Scale units, they're running. Let me show you a picture of what this whole flow is, and then I'll take you into what it's like running live. So the whole flow is looks like this in the editor. So you'll see there are these rings, ring 0, ring 1. Ring 0 is our canary. That's what I'm actually connected to right now. It's where we work. Ring 1, after things pass in ring 0, they go to ring 1, which is the 2 data centers with the smallest external user count. Then ring 2 is the data center with the largest external user count. And then ring 3 has the data centers with the highest latencies to reach, like Europe, Australia, and so forth. And then basically everything else. And when we were smaller, we did this, we would do this always in the same sequence. Now, as you saw on the other view, we're doing this in, we're doing deployments in parallel to get them faster. And indeed, if I look at this one live, right here, it looks like it just completed in one of the ring 1 centers and is just starting in progress in another one, and I could watch this proceed live as the deployment goes through. So if there's any problem, of course, it fails. We fail deployments all the time, as you can see on the reds. And what does that mean? So if you look at 1259, this failed here, but it meant that the folks attached to that data center, which I think is ring 1 or ring 2, well, they were basically on a version that from earlier in the day. Or maybe here the difference was between Tuesday and Monday. So no one is, there's no downtime. It's 24/7/365. And because we're continuously deploying, everyone is current within a day or two. And when the new deployment rolls through, it will update their replica and then do a VIP swap underneath them. So the user impact is maybe a couple extra seconds on the browser, but nothing else noticeable. So that's how a deployment goes through and looks like. And here, this one is running live as we speak. Okay. So that was roughly speaking how we go from an idea to production. Okay. Now there's some interesting things that happened along the way. So the things I'm talking about are both relevant to Microsoft in its internal use for the One Engineering system, and for us running a public SaaS, which has close to 1 million active users right now. And our on-prem product has a similar number. So, and you know, the growth in the SaaS is like this. The growth in the on-prem is still growing, just at a much shallower gradient. So we've had a bunch of things to learn, a bunch of obstacles. One of the problems we had in building a SaaS for DevOps like this is that we are building on Git. And among our customers are these internal customers with big code bases. We have this thing called Windows, which you could consider one of our big legacy code bases. Another thing called Office, which actually is even bigger. So to get Windows as an organization using Git, we had some challenges because if we took Git as it was even a year ago or 2 years ago, and you did a clone of that repo, it would take 12 hours if it succeeded. Now, if your laptop went to sleep, or the wireless burped, or anything else happened, the whole thing would start over from the beginning. So it would fail again. So, you know, what's the root cause? Well, the root cause is not that the wireless burps or that the thing goes to sleep. The problem is that Git was not architected to handle that, so we had to fix Git. That took us 3 tries. It ended up with the Git Virtual File System, GVFS, which was one of our big contributions to Git. There have been several. GVFS, the Git Virtual File System, gave us about 300x performance improvements in Git, and we now have the whole Windows team on Git. And to give an idea of the culture around Microsoft, when Windows made this move onto Git in the One Engineering system, that was the subject of Satya's monthly town hall. So he does every month, you know, a town hall where he'll talk for 15 or 20 minutes, and then it's Ask Me Anything for an hour or so, and we'll bring, you know, relevant people up with him for that event. And that month, which was May last year, it was Gabe All, who heads engineering at Windows. And that was triumphed. Now, I mentioned open source. We're trying hard to create a culture in which you're rewarded for doing the right thing, which I think is valued here too. So we're the top contributing company to Git. I don't remember who did this analysis on Medium. You'll see us as lead contributors on not just things like Git, but Kubernetes, Helm, and things like that. And now, of course, you know the news that we're the curators of, or custodians of the GitHub Forge, or soon to be. Let me flip to the lessons we've learned running a SaaS at this scale and dealing with an organization at this scale and engineering at this scale. So I put them in 5 buckets. Of course, similar to Jason and pretty much everyone else, we say customer value first. So so everyone's customer focused. Second, we look at things from a production-first mindset. I talked about DRIs. I'll get into a little bit more detail on how we do incident response as part of live-site culture, but everyone participates in that. I get pulled in for customers where I am the champ. And everyone in the engineering team beyond the new hires is expected to be a champ for a major customer. So everyone has regular conversation with customers and builds the empathy for what their life is like. Not just watch the telemetry of what they do, but build empathy. Then number 3 is how we manage to keep our feature crews or squads autonomous so they are in control of their own work while aligning with the enterprise, and how we get on a semester basis key epic metrics and goals that then the individual crews can look up at and say, oh, okay, so the next thing we need to do off the backlog to move that needle is this story, and they can do that kind of decision making. Now, in order to do this all, we needed to shift quality way left. I showed you an idea of that. So we get the failures on the pull request before the code moves to master, and we get the observability that lets us also shift right. So the level of tests I didn't show you, the L3s, are the ones in production that are running all the time on the production instance. And we can only do that because we've removed the bottleneck of infrastructure. It's all public cloud. We grab it as we need it. Let me click into the production first mindset, or live site culture, as we call it. So your top priority is always live site status. We think of every live site incident as a terrible thing to waste. We do not close the LSI until we get the repair items on the backlog. So I know we don't talk about root causes anymore, but we certainly have the discussion, what do we need to do to prevent a recurrence of this type of problem? And that may mean more telemetry, it may mean more tests, it may mean changes to code with more error handling, it may mean changes of process, it may mean all of those. And those go on the same backlog as all the feature work, and those repair items need to be closed by rule within 2 sprints, by practice within 1 sprint. We pay a lot of attention to the alerting. So if you go back about 4 or 5 years ago, typical thing was one incident, not just one screen full of alerts, but maybe 80 or 100 alerts. And it's like, well, you know, we needed these tier 1 folk who would go through and say, let me scroll down. That's the important one. Let me page that DRI from that team now, because I'm pretty sure that's the root cause. Well, we got out of that kabuki and made automation determine what the most likely suspect code is, and look up who the DRI is, and auto-page that person. Now, one of the metrics we track as part of the engineering system is alerting efficiency, how good the alerts are at picking up the right thing, and paging efficiency, how good the system is at getting to the right DRI on the first hop, so that you don't have that person say, oh, wait a minute, this doesn't look like my area. Let me hand it off to this other crew. And we review all of this stuff on a monthly basis with a bunch of metrics about how good we are at that engineering system and improving that. And we invest in it. We invest about 20% on a standing basis in engineering improvements. And we manage that as an epic like every other epic. I talked about DRIs. We have an SLA model. We promise an SLA of 9995. But by the way, I just want to say something about SLA. People sometimes talk about SLA as a goal. That's nonsense. The goal is 100% availability. The SLA is the point at which you're far enough from the goal that you give people money back. We will calculate SLA down to the organization and the user in the organization to determine who's affected. And if there is an outage that has any kind of impact, we'll blog about it with the diagnosis we found. And then we look at this for every microservice and every crew as to how they're doing on live site, in addition to how they're doing on velocity and feature delivery and usage. So how's this working? Well, we are in these feature crews in team rooms. So we're doing it the inverse Conway's law thing, if you're into that kind of talk, where we assume that we will ship our org structure. So we structure our org to be like the software we want to ship. And the crews who are working on the same area are physically together. And when they want to do their stand-up, they just walk to one side of the room and stand up. If someone's remote, they roll in what we call a Skype bot, which is basically a machine on wheels with a camera and reasonable audio, and person participates remotely from this thing that's wheeled in. They manage themselves. They stay together for typically 18 months, sometimes a little shorter. And we bring work to the crew, work to the people. We don't try to move people around for the work. They own, in production, what they build. So they're the ones who are doing that DRI duty, and it rotates across everyone. Now, I said they stay together for about 18 months. Here's what happens at the transition period. We've done this now 4 times. We get the leads of the crews to stand up in a room like this, and everyone gets a couple minutes to say, hey, we're with Z. This is what we're working on. We're the best because. And then the next crew comes up and says, we're working on this other thing. We're the best because. And so the crews from at a geo, every site does this, will do this, and then every engineer gets 3 sticky notes and gets to say, here are my first, second, third choices for where to work. And we will then go through and try to maximize first choice. It's worth saying we've done this 4 times. We've always done well over 90% first choice. It's worth noting that people don't move around as much as we expected. We have something over 20% folks who move around. But knowing that they will have the opportunity has had a great impact in knowing, hey, you know, maybe I think I'd, rather be over there doing that and learning about this thing. But, I'm committed here for the next few months, so I'm doing what I'm supposed to do with the crew I'm working with. We all know each other, and I know I'll have the opportunity to switch. And that promise makes a big difference. We have an event a good deal bigger than this called One ES Day, where we celebrate the One Engineering System. And there are, this is an old slide. There were this year something like 50 breakouts. The really energetic area is the exhibition area, where anyone who's doing something that might be of use to someone else in the company can stand up a booth. And I must say it was hard to walk through this year. So we need to get a bigger space for it. Let me spend a moment on measurement. It's a great topic. It's certainly true you can't improve what you don't measure. We measure in 3 buckets. Everything about customer usage, starting from how we attract them, to how we get them to sign up, to how we get them from first sign up to being highly engaged users, their satisfaction with Net Promoter Score, do any churn out, and we track that down to individual features. So we're looking at satisfaction at the level of features. We track everything about our velocity, what I showed you basically, getting from idea or change into production. Track everything about life site. That is, how long does it take us to detect an incident, to communicate it to the world. We use a live blog that we run. We also use Twitter because it's a shared nothing service. If everything were mysteriously sabotaged that you know, Azure owns, Microsoft owns, it's unlikely that would affect Twitter. I think the probability went up in the last year, but that's our principle. How quickly do we mitigate the impact? That is, make customers whole, make the system available for customers, and how many customers are impacted. But then we go down to what do we need to do to prevent the recurrence. And that's where we really get the learning value out of the live site incidents. And those repair items are on the backlog. Those are tracked with other work. And we do the same thing with customer support. Now, as important as what we measure is what we don't measure. We don't try to centrally measure anything that really belongs at the level of the feature crew or the squad. So we don't measure estimates. We don't track estimates. We don't track completed hours. We certainly don't measure lines of code. We want you to write less code and reuse more. We don't get into looking at who has how much capacity. Teams self-report. They manage their own burn down. They manage their own feature velocity. And we don't do bug math, as you saw. We just don't let bugs in. If you got bugs, close them. Fix them so we're not carrying any debt. So if I take a look at the organizational impact this has had, you will see across the board the changes in the way we work and the way we deliver software. So, you know, you used to see from the old Microsoft, you know, 4 to 6 month milestones, count the bugs found, pay them down with stabilization periods that were anything but. Now we're in short sprints. Used to see a lot of horizontal teams where folks were working on the data layer or the app layer or the user experience. Now we think about vertical teams, the top to bottom of the feature and the user experience. When I joined Microsoft, the buildings all had these long hallways of individual offices. Now, the building got kind of crowded, so you often saw people sharing individual offices, but they were, quote, individual offices. All the buildings now have been renovated or are on the path to be being renovated to team rooms. And by the way, again, a team room is is big enough for one feature crew. It's not a huge open space. We tried that. Didn't work very well because it had sort of a library effect. You know, no one wanted to talk loud. You know, don't want to disturb them. But you know, if the people you're sitting with are the people you're working with, and you're working on the same thing, and you want to talk to them, you talk to them. That's great. We used to have this career ladder that talked about these are developers, SDEs, software development engineers. These are testers, SDETs, software development engineers and test. And they had separate career ladders. And guess how good the collaboration was? We now have one engineering career ladder. We used to do these big ceremonies where we'd bring in customers and have a software design review about once a year. And you know, we'd fly people in from around the world and you know, get this big room and take most of a week and show them a bunch of storyboards and mock-ups and what have you, and get their feedback, and then go off and do something that we could deliver a year or two or three later so that it would be guaranteed to be out of date. Now we engage customers continuously, both quantitatively through the telemetry we talked about, and qualitatively through things like customer champs. So we're in constant dialogue or visits to customers. We used to have these, you know, big teams. We now work on, you know, around 12 people. We found pretty good. I know the Scrum Guide says 9, but we go up to 12, and that seems to work for us. Just to keep our roadmaps quiet. Now there's a web page where you can see what we're doing and what we've released every sprint since 2011, and what we're planning for the next year and can input. Used to talk about bug debt, stabilization, none of that anymore. We had people who became excellent at writing specs that we tend to look on these days as pure waste. You do just enough documentation. You do a storyboard, if it's UX. You'll certainly do a lean spec for an API, and APIs are reviewed just like they're experience reviews for UI in order to get everyone's feedback. But there's no extraneous documentation. And our public docs are all in GitHub, and you see something that needs to be fixed in the documentation, submit a pull request. Anyone can. They're all open. I talked about the code is now open to everyone in the company by default. One of the other interesting cultural changes that is applicable in a big company, which we are, you're in the middle relatively, is that we used to have all these layers of org hierarchy. And I remember learning the term span of control, where it was important not to have too many reports. Now we flatten the organization so that you don't have a lot of bosses, you don't have bosses' bosses, you don't have those ceremonies. And the result is that we're working together and we're shipping all the time. So I mentioned this website, AKAMS/DevOps. Please take a look. There's a lot more detail there. And I will be around at the barbecue, and we'll be happy to go deep on anything. So thank you very much.